For years we've talked about quantum computing as a distant dream. A kind of science fiction magic, waiting just over the horizon. But today is December 31st, 2025, and as we close out this year, we can say with certainty that the horizon is here. Quantum computing has finally moved from the realm of pure promise into the world of tangible proof. One simple fact makes this clear. In 2025, a grocery chain used a quantum computer to plan its deliveries. The result? It slashed the time needed to solve the problem by 80%. This wasn't a lab experiment, this was a real company, saving real time on a real business problem. The quantum age has begun. This video is a journey through the real measurable wins of 2025. Forget the confusing jargon and the abstract theories for a moment. We are going to look at the stories of 4 major players. Let's start with Google. This year they unveiled a powerful new quantum chip named Willow, and they used it to do something extraordinary. They ran a complex simulation, a task they call quantum echoes. Think of it as a way to probe the chaotic dance of quantum particles. The result was staggering. The Willow chip performed this task 13,000 times faster than one of the world's most powerful classical supercomputers could. This is verifiable quantum advantage, but speed is only part of the story. Raw calculation power is useless if you can't learn something new with it. So Google partnered with scientists at UC Berkeley. They used the Willow chip to study the structure of 2 different molecules, one made of 15 atoms, another of 28. The quantum computer's results perfectly matched traditional laboratory data. Then, it did something more. The quantum simulation revealed extra details about the molecules that old methods couldn't see. Huge for drug discovery, huge for materials science. It's like a new kind of microscope seeing the universe differently. The most profound breakthrough is how Willow handles errors. Quantum computers are notoriously fragile. The slightest disturbance can ruin a calculation. For nearly 3 decades, error correction has been the biggest challenge. Willow demonstrated a path forward. As they used more qubits to represent a single piece of information, errors weren't just a bit better, they were suppressed exponentially. The bigger you build the computer, the more reliable it becomes. While some chase immediate speed, IBM is playing the long game. This year they laid out a breathtaking public roadmap. It stretches all the way to 2033. Their goal isn't just a quantum computer, it's a fault-tolerant one. A machine that catches and corrects its own errors in real time. The centerpiece, Quantum Starling, targeted for 2029. 200 stable logical qubits, 100 million operations without a mistake. The kind of power for world-changing applications. This roadmap is more than a dream, it's concrete yearly steps. 2025, Quantum Loon, test new ways of connecting qubits. 2026, Quantum Kookaburra, first chip to store quantum information in special memory. 2027, Quantum Cockatoo, links different processor modules. Each step builds toward a quantum-centric supercomputer with 100,000 physical qubits by 2033. A public plan invites scrutiny, but it signals confidence. It tells the world where they're going and how they'll get there. Even today, IBM's machines show impressive power. They're the only systems running quantum circuits with over 5,000 complex operations accurately. Like running a long, complicated program without it crashing. Companies are already using this capability. Example: HSBC using IBM Quantum for bond trading predictions. Result: 34% improvement in accuracy versus their best classical models. This is a real financial advantage now. IBM's approach is architectural, not just a chip. They're planning how to connect modules, how to store quantum data, and how to integrate these machines with classical supercomputers. While Google and IBM build toward the future, another company, IonQ, scored a major win in the here and now. In March of 2025, they announced a landmark achievement. In partnership with Ansys, they used their 36-qubit trapped ion quantum computer to run a simulation of a medical device. The result was not just a scientific curiosity. The quantum computer performed the task, 12% better than a classical high-performance computing cluster. This is one of the first documented cases of a quantum computer providing a practical, measurable advantage on a real-world commercial problem. What makes IonQ's technology special is its foundation. Instead of using superconducting circuits, Google IBM IonQ uses trapped ions, individual atoms suspended in an electromagnetic field. This approach has its own advantages. This year, IonQ announced they had achieved a 2-qubit gate fidelity of over 99.9% in a prototype system. Fidelity is a measure of reliability. 99.9% fidelity means 1 error per 1,000 operations. This accuracy makes useful answers possible from smaller quantum machines. You don't need millions of qubits if the ones you have are extremely high quality. This progress is not happening in a vacuum. It is being deployed in the real world. IonQ finalized a major agreement to install a 100-qubit system named IonQ Tempo at South Korea's National Supercomputing Center. There is another way to approach the quantum world and, a company called D-Wave is its champion. Instead of building universal gate-based computers like Google or IBM, D-Wave builds quantum annealers. These are specialized machines designed to do one thing exceptionally well: solve optimization problems. Think of it like finding the lowest point in a vast hilly landscape with thousands of valleys. This year, D-Wave announced that their annealer had achieved commercial quantum supremacy. They demonstrated that their machine could solve a complex simulation of magnetic materials far more effectively than a top-tier classical supercomputer. This is not just academic. Optimization is at the heart of countless business challenges. How do you schedule a fleet of delivery trucks to be as efficient as possible? How do you organize tasks on a factory floor to minimize downtime? These are billion-dollar questions. And in 2025, D-Wave provided real answers. Ford Otosan, a major automotive manufacturer, used D-Wave's technology to optimize their vehicle paint shop scheduling. The time it took to generate a schedule dropped from 30 minutes to less than 5 minutes. This speed allows them to react to changes on the factory floor in real time. We mentioned earlier that a grocery chain used a D-Wave quantum solution to optimize its delivery schedules. That resulted in an 80% reduction in the time it took to calculate the best routes. Imagine the savings in fuel time and emissions. This is the promise of quantum optimization made real. It shows that even specialized quantum devices can deliver immense value today, without waiting for a fully fault-tolerant universal computer. The money trail market growth and investor confidence. As astrophysicists do, to understand the universe you have to follow the light. To understand a new technology, you follow the money. And in 2025, the money is flowing into quantum computing like never before. The global quantum market is estimated to have reached $3.5 billion this year, with a staggering compound annual growth rate projected at over 41%. Forecasters predict the market will balloon to over $20 billion by 2030. This isn't just speculative hype. This is investment driven by the tangible results we've been discussing. The industry is on track to generate over $1 billion in revenue this year alone. The public markets are telling a similar story. Look at the pure-play quantum companies. In the past year, D-Wave's stock has surged by an incredible 3,700%. IonQ has seen its value climb by 700%. And Rigetti Computing has hit all-time highs with a 5,700% gain. While stock markets can be volatile, a surge of this magnitude across an entire sector is a powerful signal. It tells us that investors, from large institutions to individual traders, are looking at the evidence and betting big on a quantum future. In just the first 3 quarters of 2025, quantum computing startups have raised $1.25 billion in new investments. This brings the total equity funding in the space to nearly $4 billion. If you find these explorations of science and technology as exciting as I do, please take a moment to like this essay and subscribe to our channel. Your support helps us continue to bring you clear, evidence-based stories from the frontiers of human knowledge. This flood of capital is the fuel that powers the engine of innovation. The financial world has done its due diligence, and its conclusion is clear: quantum computing is no longer a science project. Why 2025 is different: the end of killer errors. For decades, there was one giant obstacle standing in the way of useful quantum computers: errors. Qubits, the fundamental building blocks of quantum information, are incredibly sensitive. A stray magnetic field, a tiny temperature fluctuation, almost anything could knock them off course and destroy a calculation. This fragility was the field's Achilles heel. But 2025 is the year we finally turn the corner. Multiple labs reported achieving record-low error rates, some as low as 0.000015% per operation. That's a level of precision that begins to make large-scale computation feasible. The true breakthrough, however, is not just making better qubits, but finding smarter ways to use them. As we saw with Google's Willow chip, we have now crossed a critical threshold in quantum error correction. For the first time, we can group physical qubits together to form a more stable logical qubit. And as we add more physical qubits to this group, the error rate of the logical qubit goes down exponentially. This is the holy grail that researchers have been chasing for 30 years. It means we finally have a scalable recipe for building reliable quantum machines. The bigger we build them, the better they will work. This progress is not limited to one type of quantum computer. We are seeing improvements across the board. The coherence times, the length of time a qubit can hold its quantum state, have seen significant gains. Researchers at NIST, the National Institute of Standards and Technology, achieved coherence times of up to 0.6 milliseconds for superconducting qubits. That may not sound like a long time, but in the quantum world, it's an eternity, allowing for thousands of complex operations to be performed before the quantum state is lost. In conclusion, your place in the quantum future. So, we stand here at the close of 2025, looking back at a year of undeniable progress. We have seen Google achieve a speed-up of 13,000 times on a real scientific problem. We have seen IBM lay out a clear, credible roadmap to fault-tolerant machines. We have seen IonQ deliver a 12% real-world advantage in a medical simulation. And we have seen D-Wave's customers slash their optimization times by 80% or more. These are not vague promises, hard numbers, concrete results, real-world applications. For the thoughtful skeptic, the question is no longer if quantum is real, but how it will change their world. Sources. The information presented in this essay is based on publicly available research, announcements, and market analysis from 2024 and 2025. Key sources include Google AI Publications, the Willow Processor, Google AI Publications, the Quantum Echoes algorithm, IBM research announcements regarding their fault-tolerant quantum roadmap to 2033, SpinQ research press release on medical device simulation with ANSYS, IonQ press releases on hardware fidelity achievements, Network World Report on commercial quantum supremacy, D-Wave Systems reports on customer optimization results, Industry Week article on commercial application at HSBC, Industry Week article on commercial application at AstraZeneca, Markets research analysis of market size and growth rates, Financial Times analysis of public stock performance, Nature Physics publications on advances in quantum error correction, NIST publications on qubit coherence times.